Good morning, everyone, wherever you may be. Welcome to a very interesting show. Today we've really got something amazing because we've got Jupiter live. So I just wanted to be sure that you can also comment. So don't forget to write any comments. I'm just going to quickly write a comment here. Say hi, everyone. So you can be sure, say hello, and it would be great to hear from you, so that I know that I'm really live, which I probably am. So what you can probably see is the screen again of our wonderful telescope. We're broadcasting live from Siding Spring here. Okay, so today we have something really remarkable. So what I want to actually show you is Jupiter live. And to show you Jupiter live is actually quite complex because the planet is very small from its dimensions, and you may have seen some of the some image of Jupiter in the past, maybe as a child or so, or maybe you've been to an observatory and actually seen the beautiful planet of Jupiter. To show it live is not that easy because its dimensions are rather small. So what I will do is I'm going to take a jump now and show you the observatory. So this is a live view of the observatory at the moment as it is, and you can see that the telescope that we're using is very much on the left. Let me just put an arrow there. 1 second. Let's see where we have it. It's 1 second. I have an echo somewhere and I'm not sure where it's coming from. So just bear with me. I have a small technical problem here that I'm not wanting. So just bear with me 1 second. I have a small technical issue here. There's Peter Carson. Hi from England. Just bear with me 1 second. I'm not sure where I'm getting the echo from because this is absolutely not wanted. I hope you don't hear the echo, but I'm hearing a slight echo, and I actually muted all my microphones, but because the system is so incredibly complex, it's not always perfect. Okay. Let's see how I can mute this. I'm not sure how this is done. But anyway, hopefully it's okay. So what you see there is a live view at the moment of the observatory. I'm going to point my arrow right to the telescope that we're using. The telescope that we're using is a huge telescope. It's pointing northwards. We are in Siding Spring here. And you can see there's a lot of moonlight, and moonlight is very difficult for astronomers to do anything. So the best we can do at the moment is actually look at Jupiter, because Jupiter is very bright. And that's exactly what we're going to do. Now, oh, you can't hear an echo. Well, that's great, Peter. I'm glad you're not hearing an echo. That's good. So it's maybe only my very sensitive ears. That's good. That's good to know, Peter. Thank you. Great. So you're not hearing an echo. That is good. Glad to hear. Okay. So the telescope that we're using is where the arrow is pointing at the moment. This is a live view of the observatory, actually, and it's 3:03 local time AM. The telescope is pointing northwards. So Jupiter is about 60 degrees up at the moment, fairly high in the sky, and you can see the observatory is beautifully illuminated by the moon, and telescopes are pointing in all kinds of different directions, doing different things, but we're using the super telescope, which actually has two different cameras on it. So it's a very complex system. So I'm going to operate the system, talk to you at the same time, read your comments and so on. So bear with me if I'm not perfect, because this is really stretching it to the limits what I can do as a single person. I've got crazy monitors around me, but anyway, I hope you will enjoy it. So I'm just going to make a jump now to the other. I'm on another screen here, so I hope you can see this. I'm going to switch on the Widefield camera and start it now. So there you can already see beautifully, this is the Widefield camera that actually captures Jupiter and all its moons. And if you Google the current positions of the 4 main moons from Jupiter, you will see that they are, I think it's, yes, that should be, I see it now. This is Europa, one of the big famous moons. You've heard of it from the famous film Space Odyssey 2001, The Journey to Jupiter. So that's Europa. The other one close by is Io. Io is a very, very fascinating moon because it has a lot of volcanic action. And then these both here are both Callisto and Ganymede. So these are the famous 4 moons that Galileo already saw many hundreds of years ago. He was the one who discovered them. In the meantime, we do know that Jupiter has around 63 moons. It's absolutely crazy, but that's only possible because the most of the moons are very small. You can discover them only through journeys which were done. So let's jump right into Jupiter. So that was a live view, and we're going to see a lot more of Jupiter with a narrow planetary camera, and that's where it gets very interesting. So let's talk a little bit about Jupiter. So Jupiter has a distance about 780 million kilometers from the Sun. In astronomical units, it's approximately 5 times. So we say 5 astronomical units, whereby an astronomical unit is defined as the distance between the Earth and the Sun. So it's 5 times that distance. That means if you hold your hand out, how big would the Sun appear? Well, the Sun is typically the same size as the Moon when we look in the sky. So if you held out your hand, the apparent diameter of the Sun would be 5 times smaller, but the area that actually, the heat that would arrive on your hand would be 25 times smaller because it's proportional to the square. Okay, so you get very little heat, which explains why it's quite cold on Jupiter. Now, Jupiter is really fascinating. It's got a radius, and I say approximately, of 70,000 kilometers. In miles, that would be, let me just translate this quickly into miles. That's roughly 48,000 miles. So light takes from Jupiter to Earth would be 8 times, 8 times 5, so it's a little bit over 40 minutes. So what we're going to see, the pictures, any pictures. Hi, I'm seeing Mike here too, watching from Alabama. Wonderful. So you're 3 hours ahead of me from Alabama. Welcome. Welcome to the show. So Jupiter is really, really fascinating. It takes also around nearly 12 years to have a journey. So we take 1 year, it takes 12 years for Jupiter to go around. It's a massive planet. I think the gravitational constant, if you were to stand on Jupiter, you cannot stand on Jupiter. It's such dense clouds. It's really crazy. We'll get to the composition of Jupiter shortly. But what's interesting is the rotational speed of Jupiter is so incredibly fast that on the equator, it rotates faster than the poles, and that causes a strange bulge. It's certainly all but a sphere. So at the equator, it's very, very wide. And then you have, of course, the famous red spot, which you can see occasionally. So if you were to take a movie of Jupiter, you would only expose it for about a minute because it moves quite a lot in a minute. Isn't that amazing? Hi, Rachel, watching from northwestern New Hampshire. That is great. And I have Volodymyr. Is that right? Do I pronounce your name correctly? Maxi from the Ukraine. That's very good. Well, that is wonderful. So we have visitors all over the world. That is so great to see. Okay, so we'll get back to Jupiter in a second, but before we get to Jupiter, let's switch cameras. Now, this is where you have to really be patient with me. I will once more show you, for those who've just joined, I will show you the live view of the telescope. There we are. So it's the big telescope on the left, okay? And you can see it move slightly. You may have just seen it, the refresh. So what this telescope is actually doing, it is following, watching from the UK. Don't tell the boss, I won't tell the boss, Al. I won't. And Scott, you're there from Pennsylvania. Wonderful, all these people. Hans is there from the Netherlands. Hey. Hoe gaan dit? Oh, Netherlands too. That is great, Hans. So we got people from all over the world watching. Well, this is so exciting. So we're going to operate this wonderfully big telescope now. So this telescope has, and I'm just going to put an arrow back here. That's the telescope we're looking at. Has 2 different cameras on it, at least. There are more. Oh, there's another from Newark. I've got all these people, and from Michigan, cold Michigan. My goodness, you know we've had Ed. We've had a terrible winter here in Vancouver. We usually are very, very mild, but it's been goodness me, it's been snowing till very, very recent, and I've hardly been out. So I'm going to be in Australia very soon, broadcasting live. Edinburgh, Scotland. Edinburgh is so lovely, isn't it? And hi from Eastern Canada, that must be cold. Oh my goodness, I was talking about Edinburgh yesterday, Graham. What a beautiful old city it is. You know, when I we used to live in the Midlands, in Stafford. I used to take the train sometimes up to Manchester, then Edinburgh, and so on. So it's such a lovely place. Very nice. It's a beautiful university town. Watching from Italy, hey, Federico Senisi from Italy. That's wonderful. And from Toronto, hey, it's wonderful to have all your comments here. That makes it so much more enjoyable. Okay, well, great to have you all. Let's switch cameras now. So what you've just seen is the Widefield camera. That's the Widefield camera. Okay, and we've just seen the 4 moons. Okay. Easily be seen. Wayne is watching from Seattle. That's not far. It's, you know what lousy winter it is. Yes, it is. And Peter says Boston. Now, Boston is cold, but Boston is so beautiful. It's so European too. It's such a beautiful European place. I always think when I go to Boston, I feel like being in Europe because I'm very much a European. So it's a wonderful place, even though it's cold. Okay, so we're going to switch now from the wide field camera to the narrow field, because in order to see Jupiter, and you can see it's just right here in the center, we have to use a different type of camera. So I'm going to switch cameras now, and I will explain how I'm doing all that live. So I'm going to open, and you can see that here. I'm just going to point my arrow here so you can see what I'm actually doing. This is sophisticated stuff. This, you can see the numbers 1, 2, 3, and 4 there. We are using camera number 1. This is so sophisticated, and if you can just read it on your screen, it says under 4, it says planet. So I'm going to press planet now, and it's going to switch cameras, okay? So we will switch cameras. The other one is not, it's still got a static picture on, and now I have to switch to a different type of software, which really makes it complex. So we are going to go over, and you can see there's a big blur there. Now what is that doing? The camera is out of focus, right? It's out of focus. So you can see the spot move. That's Jupiter, in fact. But we have to get Jupiter into focus. So what I'm going to do now is get Jupiter into focus by changing the focus remotely, which is a little bit different to when you just press your camera focus. Okay, it does it all automatically. Well, here I know the settings, so I'm going to put a different type of number in here. Let me just show you what I'm doing here with the arrow. This, where the arrow is pointing now, that is my focus. Okay, so I'm going to now change the focus, move to, and you will slowly see Jupiter getting smaller and smaller and more focused, okay? So because it's a different camera, it has a different focal length, right? There's different focus, and it's going to, you can see it's moving in. So I'm just going to decrease the sensitivity of the camera. Otherwise, it's going to be a massive spot here. So you will soon see it appear here as a planet, okay? So you can see it's getting more and more focused now. And it's all live. what you see, the shaking of Jupiter is not the shaking of Jupiter, it's our atmosphere, okay? So even at 60 degrees at the moment, the atmosphere is fairly turbulent, okay? So you can see it's getting brighter and brighter, so I'm going to turn down the gain of the camera, which is like turning down the ISO, or the sensitivity, more and more. And as it'll get more and more to focus, let's see, yeah, there we go, we're there, and we're right in focus now. Beautiful. We're just going to turn the gain, and then I'm going to enlarge the screen for you, and there you go. That is a live view of Jupiter, and it's quite incredible actually, because you'll say, well, that's not in focus, right? It actually is very much in focus. It's the atmospheric turbulence, and the trick that we usually use in order to circumvent the atmospheric turbulence is we do a recording, right? You take a recording, because there are instances in our atmosphere where the seeing, and we call the seeing, is very clear. You know, it's the same as walking through the desert, and there's a moment when you don't see so much shimmering. And so what we do is we take a recording, a 30-second recording of Jupiter, and then there's some special software that selects the best images and stacks them. Stacking just means putting them together to get a better signal to noise ratio. But already, you know, this is a live image. Now imagine Jupiter is a tiny, tiny spot there. So we are using a focal length here of f32, which is quite incredible. So that's the live view of Jupiter. Now you can say to me, well, where are the moons now? Well, the moons at the moment are underexposed. We should be able to see the moons. Let me just completely overexpose for a second. See if I can do this live. And maybe we'll be able to see a moon nearby. Because this is so enlarged. Let me just see. Well, not close by at the moment. I would have to move the camera backwards and forwards, which I don't want to do at the moment, or the telescope backwards and forwards, because otherwise I'll lose Jupiter. But you can see how incredibly sensitive it is. So here's Jupiter and its amazing bands. So let's get going. Let's talk a little bit about Jupiter. Now Jupiter is fascinating. I will just bring in another screen, get rid of the arrow, and then we'll get straight back. So, what is so exciting about Jupiter? Jupiter has, first of all, consists mainly of hydrogen and helium. It's about 90% hydrogen, not surprisingly, and a lot of helium. So if you were to fall into Jupiter, it would first look very much, and I mean, I'm really speculating here. In the beginning, it would seem very cloudy. Then it would get more and more dense, and it would get very, very unpleasant. Of course, you can't breathe in hydrogen and helium, and eventually it would get so dense and so incredibly uncomfortable. But it would get uncomfortable for many other reasons. Another reason is that Jupiter has a massive magnetic field. It's massive. It's 20,000 times the magnetic field that we actually experience here on Earth. So it's absolutely lethal. It's beyond everything, and it destroys it destroys any spaceships, because how much lead would you actually need to protect yourself from any type of radiation? Because what this causes, all the all the strong magnetic field, is of course you get incredible auroras. Very, very strong auroras from particles, and this would be absolutely lethal for us, okay? So the radiation belt from high energy particles would be an absolute no-no for missions, so no landing on Jupiter. You would be about 2 times heavier if there was a surface you could actually stand on. So it also contains some helium, minor amounts of methane, ammonia, hydrogen, some hydrogen, ethane, water, ice aerosols, and so on. So there are a lot of poisonous stuff there. And what's interesting about Jupiter, it seems to have a very dense core. Nobody quite knows what it is. I mean, this is a lot of speculation, but it's very possible through the incredible gravity that you have at the center that Jupiter actually consists of what we call fluid metallic hydrogen. You may have heard that a few months ago there was a major breakthrough where they made metallic hydrogen as simple as it may be, the simplest form of an atom just with an electron and a proton is actually very complex, because when you put a lot of pressure on it, incredible pressure on it, you can actually condense it, and you will force it into another state, which is a metallic state, and this that's why it's called fluid metallic hydrogen, and it's very possible that the core of Jupiter is a fluid metallic hydrogen. Now, there are other speculations too. Some think there's a massive diamond in there. Can you imagine if there was a massive diamond, what expeditions would start? If you could ever get... Some speculate there's even a diamond or carbon rain on Jupiter. How much of this is confirmed, I don't really know. Interestingly enough, it has 63 moons. And the biggest 4 moons we already just saw, they are Io, Europa, Ganymede, and Callisto. Okay, so that's so much. And then, of course, the rotational speed of Jupiter, even as you're watching it now. Unfortunately, the red spot is not visible at the moment, but the red spot, and let's go back to the live view now. Let's see where my arrow is. So the red spot usually appears would appear sometime on the left and then move to the right. Yesterday, there's another. Hi, welcome, Selvam. Very good to hear from you. Glad that there's so many here today, because this is quite exciting. So this is Jupiter and its gas rings. Okay, and what's incredible is, of course, there are enormous storms on Jupiter. What is interesting, I was just talking about the red, the famous red spot, which I'm sure all have heard of. But the red spot actually turns counterclockwise. It's crazy, and it's a very, very turbulent storm near the equator. I think it is moving approximately at 400-500 miles per hour. It's incredible that you would have storms that last for such a long time. So Jupiter is absolutely fascinating. It's also a type of vacuum cleaner. There have been some, you may have seen it in the news, that it does absorb a lot of asteroids, in a type of a vacuum cleaner and protector of the Earth from a lot of the from dangerous asteroids. So it does act as a shield. It's very interesting. So that's as much as I've just could talk about Jupiter in detail. So it's vibrating quite a lot through the atmospheric conditions. But what I will do is I'm going to take a quick video now I just want to demonstrate to you how I do this with the software. So I have my software control here. You can see that on the right hand side, and I'm going to press here record, and you can see it's recording now. I've got different types of filters there. What you can see is we are seeing Jupiter at the moment in black and white, and you can say, well, why are we seeing it in black and white and not in color? Well, that's a very fair question. Hi, John from New Hampshire. Wonderful. Another from the East Coast. That is great. Sandborville, I don't know where that is, but I have to look that up. I've been in New Hampshire, but I've not been there. Good to have you here. So this is so we're recording, doing a 30-second recording here of Jupiter. What I do afterwards, and I can't do that live, is I would stack the images, and then we actually would get a beautifully stable, quite clear image of Jupiter. And that's the trick, because what you see here is, of course, a lot of turbulence. It's jumping up and down. And that's a live view, but nevertheless, you can see very, very clearly if you look at the dark bands on Jupiter, you can actually see, if you look very, very carefully, you can see that all the turbulence in the dark band. So it's quite remarkable, actually, even as we have a live view at this incredible magnification. So we have a black and white camera. It has different filters. So if I wanted to take a color image, I would first take what you call a luminance. That's taking the whole spectrum. That's the whole visible spectrum of Jupiter. And then I would take a red, a green, and a blue image of them. Okay, and then we would superimpose them, and we could get a color. Well, then you say, well, why make it so complicated? I've seen color images of Jupiter before. Yes, you have. And there are color cameras that do that. But the color cameras don't have the same sensitivity. Because even your pocket camera that you use actually takes the visible light and it splits it through different filters into red, green, and blue, and so you lose a lot of sensitivity. Now, in most cases, it doesn't matter because you have enough light you have enough sunlight, and also the cameras have become so sensitive. But when you go to astronomy, you want to go to high resolution and so on, and every pixel counts really. So that's why we use much more sensitive cameras. This camera, for example, is cooled to minus 20 degrees Celsius. So it's quite a small, very compact camera, but it's very sophisticated. Okay. So what you see also at the bottom, you can see some. This looks. Let me just put my arrow there. You can see that's all these blue bars coming up. That's like a histogram. It shows us a live histogram of Jupiter. Tells us what the sensitivity is and so on. And by reading it, I can adjust the focus, which I don't need to do because I focused it. Hi, Pamina is also here. Very nice, Pamina, to have you. She's from, I think, from Mexico. Wonderful to have you. Wonderful to have you all here. That is great. Well, that's fine. That's all I wanted to tell you about Jupiter. So let's just jump again. If you have any other questions on this incredible king of planets, just throw them at me and I will try and answer them. But I think it was quite exciting to see this live. I'm just going to show you the telescope once more. Let's go back to it. There we go. That's the live view. So you can see that's the telescope that we're using on the very left side. I could nudge the telescope backwards and forwards, but I won't do it. Otherwise, I will lose Jupiter. But all this is remotely controlled now. And as you can see, it's beautiful lit up here. All the different telescopes we have. Different telescopes, by the way, that you see here. I just want to point another arrow. That is a refractor that you see there. It's a Takahashi. We use it for Widefield. So if you want to take beautiful nebula, that's what you would do. John in California. How soon will this camera and video stream will be available to iTelescope members? Thanks for the great show. Well, thank you for your kind words. Well, that is, this is a great question. If that is something, my question then to you is, how interesting is planetary imaging for members? Okay, if it is very interesting, I'm going to Australia mid-April, and hi, there's Chris talking from not far from the Okanagan. Well, I've been to Penticton very often, the Okanagan. But coming back to the question, planetary imaging is, I think, very interesting, and I'm also going to use the planetary imaging in a few months' time to show you the moon incredibly close with the same telescope. But if this is something where there's enough interest, I think that is something that could be implemented into one of the telescopes. Probably, for example, T17, one of the telescopes, we could probably put a planetary camera there. If there's something of interest, why not? So, that's maybe something I'll bring back to the, to the board of iTelescope, and we can discuss that. So that's good to know. If you're very interested in doing planets, Jupiter and Saturn. Saturn we're going to do in April, by the way. Saturn will be high up, and there's another show. Very much interested, says Mike. Well, that's good. Okay, well, it's great that you're also interested. Then that means that you're as crazy enthusiastic as I am. So that's good. Rachel, is there any hint of a solid metallic core in Jupiter? Or is it just, it is speculation, Rachel. As far as I know, it's all speculation. I should try and get a planetary expert actually to answer this. But from my own understanding, it is a calculation of the density of Jupiter and saying, well, it is very likely that the core is so dense and could be a very dense gas, but it could be so dense it could actually be metallic. It is unknown. It is not known is the answer. But it is a great question, and hopefully we'll know one day. Hopefully we'll know one day, as hopefully they put more money into science, which I think is so important. So I think very much. Al says, also interested in iTelescope Planetary. Well, that's good, Al. I'm glad to hear that. I'm glad to hear that from some of the members. And Ed says, I think we could get outstanding pictures of the moon. Yes, you can. You know, this is great. This is really great stuff. And JM Grive says, very interested in planetary. Great. Well, that means there's a lot of interest. You know, I could also show you once how to use the iTelescopes to get a marvelous, marvelous picture of the moon. I've done it yesterday for fun. Ditto, good, Mike. Well, that's great. I'm glad there's so much interest in this. I will bring it back. And as I said, I'm going to be in Australia from the 19th of April to the 4th of May. So I'm leaving on the 17th. I'll be driving around with a camper van and doing some live broadcasts as I go. So it's going to be very interesting. I'm going to spend a few days in Siding Spring, and I will be there right in the middle of Siding Spring, showing you everything live. And that's the time also where we can discuss such things. I think it's great to have you here, and it's great to have your interest and input. So I'll take that definitely on board. Okay. Good. Well, let's just as we close now, let me just go back to our central control now. Let me just find it. Where is it? I've got so many windows open here. Yeah, there it is. So I'm just going to, whoops, that was one too much. I'm going to bring my arrow back so you can see what I'm pointing at. This is the central control. Watch out for the ruse. I will. No, you know, Mike, that's absolutely serious with the kangaroos, because they are quite a menace when you drive. I will be very, very careful. Is the turbulence that we are seeing live typical of the seeing general at this site? Seeing is usually quite bad. You know, that's a great question. It depends. The seeing depends a lot on the humidity. It can vary. Usually the seeing in Siding Spring is absolutely exceptional. The air is usually very dry. But the way to read it, Peter, and that is very, very important, is to go on the weather, to see the weather, and you have to look at the dew point in relation to the temperature, and that ratio will tell you how dry it is. We've had in the last days some very humid days, but it usually is, the seeing is usually very good, but it can vary. I haven't looked how good the seeing is now, but it varies, and usually the seeing is very good because it is used by professional astronomers. You've probably heard that there's a big 4-meter telescope and so on. So the seeing is very good. I know that in England it's terrible. I lived in Stafford and the humidity is absolutely crazy. So it has a lot to do with the humidity. And actually the seeing in general is very good. So that is the answer. But again, it depends also on the elevation. Saturn will be up in April. And let's do another experiment with Saturn and see how clearly we can get it. Okay, so I'm just going to jump back to, I'm going to press button number 1, and you will see this dot has just moved to the position 1. And let's take one last look at the camera now. Where is my camera? Oh no, that is, oh, by the way, that's also great. This is how let me just show you that. I just opened the wrong window, but you can see here that is the sky live. That is how the telescope is actually controlled. And you can see there's Jupiter, by the way. Now, let me just get it close to Jupiter. So that is how we control the telescope from remote. So it's quite sophisticated stuff here. We got so many windows, so I'm doing all that simultaneously. But let me just get up the software again. That was what I wanted to do, and give you one last look. Okay, let's take another live image of, there we go. I'm going to start it again. The camera is going to go now, and let's see. Oops, you can see what's happened there. It's not focused, right? That is a live view. So let me get it back into focus now. Does iTelescope have a seeing monitor output as part of it? You know, this is a great question. When a data feed, at the moment, Chris, I've got hi, Hal is also there. That's great. Good to see Hal there. That's wonderful. Chris, I'm using a direct link at the moment because Usually the interface that we provide for users in iTelescope is all via the via the application form of iTelescope that you usually use. So I'm using a sub level here to really manipulate this telescope, because it's a very, very sophisticated telescope that is not available for all the members at the moment. This is a private telescope I'm using here. However, this is something that is if you're looking for a monitor to actually see the observatory, that is something that we can discuss if that's of interest. And for planetary, it's going to be very interesting anyway to implement a camera. So I will, this is all great input. I'm very happy we're having this discussion. So when I'm in Australia, in the middle of all these telescopes, we can discuss all these things, okay? So let me just run the focus back to the original position, if I have all this in my head, all these numbers. So I'm just going to run a continuous focus now. So as it runs, you should see this is going to focus and the moons will suddenly appear. Okay, so you can indeed see this is all live. It's refocusing right now. So I just want to give you that as a final, just as a final enjoyment of the way telescopes operate. It's amazing what we can do nowadays. By the way, this is a beautiful telescope that we have here, and possibly later I will also be showing star spectra with this. Star spectra is so interesting. They're such incredibly interesting stars that tell a lot about the history, about these stars, the composition, and so on. So we can do some beautiful things. You can see now slowly, if you look carefully, you can see the moons appearing again. There you go. So there come the moons again. They're coming back into focus. And there we go. It's almost focused now. There we go. So that's the final image. Okay, my friends. Well, thank you. I hope you enjoyed this unique show on Jupiter Live. I will make this available for you. Oh, what I mean is a live readout of sky seeing. I see they have one in New Mexico skies. I get it, Chris. So what you mean is a live seeing. I have to go back. I don't know how live the seeing actually is, but with seeing you really mean minute by minute. I will see about. That's a stupid pun, isn't it? I will see about seeing. I will. I'll get back to you on it. Watching from Cape Cod inside Observatory with a group of 6th grade students. Very inspired. Hey, that's wonderful. That is so great from Cape Cod. Well, welcome all you 6th grade students. That is wonderful. I want to also open this to Scott Gardner. Thank you. I want to open this also because we are so pleased to have young people. And if you want to participate and do some live imaging, contact us at iTelescope. I'd love to do that with you, and show you how it's done. We can do the Orion Nebula, all the wonderful famous things we can do, and get you interested in astronomy and give you the real feeling of it. Okay. Okay, my friends. Well, thank you. Thanks would be interested in accessing camera on big scope. Good. Well, there's a lot of interest for planetary. I can see that. There's interested for seeing better, seeing live. I've got all that. And it's wonderful to have you all. Got it. Okay. Well, thank you, my friends. I hope you enjoyed it. Have a wonderful Saturday or Sunday, wherever you may be. It's Sunday already in Australia. And we'll be back next Saturday live again. Yeah, Saturday live. That's a good one.